Hello and welcome back. In this video, I'm going to work with data regarding the total number of companies in Spain and the total number of companies in the region of Madrid. Okay, so what we are going to do now is to introduce some new functions that I will be able to obtain when working with the data I have here. Okay, so as you may know, we can introduce a function with the option of clicking here in the insert function icon. Okay, and here, what I'm going to do now is to look for covariance, okay? So here I have several options. You can see that I have two different covariances. We have the covariance S and the covariance P. In this case, I'm going to work with the covariance S. S stands for sample, while P stands for population. Okay, so let's choose covariance sample. Okay, we will insert the function, and now Excel will ask me for the data I want to introduce in this function, okay? So the first matrix or the first array of data will be the total number of companies. In Spain, I will drag down till I reach the last year I'm considering here, okay? And then I will do the same process for the second matrix, okay? I will click again on 1999, refer to Madrid. I will drag down, and then here I will have all the data I need. Okay, so I click on done, and here what I have obtained is the covariance for those two variables. Now I'm going to change the format. Okay, I will use a number. Okay, excuse me, and I will introduce the separator. Okay, so here we have a really large number that we are going to analyze. Okay, so the first thing we must take into consideration is that the covariance is used in statistics, and it will measure the joint variability of two random variables. In this case, my random variables are the total number of companies in Spain and the total number of companies in Madrid. So I have a positive number, and having a positive number is telling me that there is a positive relation between both variables. Okay, indeed, we can see that here, if we start with 1999, the number of companies in Spain will decrease, and same happens with Madrid, okay? As we keep on advancing through time, it will also decrease. So we have a positive relation between both variables. But how strong is this relation? Okay, that's the problem with covariance. It is giving us some information, but still we could go a bit further in our statistical analysis, and that's the reason that I'm going to introduce a new function. And this new function is called correlation. Okay, so here we have correlation. Okay, we will insert the function. Okay, let's go back for a moment because I want to introduce it here. Okay, just below the covariance. So I will click on correlation, I will insert the function, I will use the same data here. Okay, so now I go for the second column. Okay, here it is. And then I click on done. Okay, so here we have 0.99. We will use just a couple of decimals. Okay, we go to number, two decimals. Okay, and this is the correlation. Okay, so once we have obtained the correlation, we can go a bit deeper into our study regarding those two variables. Okay, so we still have a positive number, so it is telling us what we already know from the covariance value. Okay, that there is a positive relation, but the interesting thing here is that the correlation coefficient will be always between -1 and 1. Okay, so what does it mean? That, well, being positive, the value that I have obtained with the correlation, indeed it is 0.99. I know that the correlation is direct between both variables, but the good thing here is that I know that the correlation is very strong. Okay, indeed, we are very close to one. One is the maximum value. Okay, so here we have some more information that is really valuable for us when analyzing two random variables. Okay, so suppose that, for example, if we obtain a correlation coefficient of minus 0.82, excuse me, minus, yes, I said correctly, minus 0.82. Suppose that I have this value, well, I would still have a strong relation between both variables, but now the value I have is negative. So what does it mean? Well, it means that the relation between those variables is not direct, it is negative. Okay, so it would mean that on one hand the companies in Spain could decrease as we keep on advancing, but on the other hand the companies in Madrid would increase. Okay, as one variable is being decreased, the other variable would be increased. So we would have a negative relation between those variables. So the coefficient of correlation is going to measure how strong is the relationship between two random variables, and its main advantage is that it will give us values between -1 and 1, and accordingly will be easier for us to make an interpretation on how those two variables behave when studied jointly. Okay, so once we have introduced those two concepts for covariance and correlation, we have seen how to use the insert function option on Excel. Okay, you will learn more about those two concepts during your statistics course. Okay, but now we are going to do something else. Okay, as we're working with two variables. Okay, now what I'm going to do is to plot both variables into one graphic. Okay, so I will make a selection. Okay, I will click on insert, and in this case I will be very specific. I will choose the first scatter plot. Okay, so here it is. I will move a bit. Okay, so we can see all the information we have. I will change the title of the graph. I will call it, for instance, total number companies. Okay, and I will say Spain versus Madrid. Okay, so now I have changed the title, and here I have the blue dots that will represent the coordinates from those two variables. Okay, regarding each year I'm considering. So now I'm going to click on the blue dots, and I with the left click on my mouse, and I will right click again my mouse, and here we have an option that is called add trend line. I will add the trend line. So here we have a new line, okay, that is giving us a hint on the trend, on the tendency, but I have a new menu on the right, and here I will choose display equation on chart and display r squared value on chart. Okay, so I have obtained the information here. I will move it a bit to the left, and well, I will change the size here. I will use, for instance, 14. Okay, so here what I have first is the equation. This is a linear equation, okay, for the information I'm working with. Okay, so what we have with the x, that is 0.2424, this is the slope. You can see it is positive. We have a positive slope. Okay, and the other number I have here, 4,867, is where this line will cut the vertical axis, that is the y-axis, when x is equal to 0. So we have an equation, okay, that will define how this data behaves. So we call this a simple linear regression. And what is it? Okay, this is a model that summarizes the relationship between two random variables through a linear equation. Okay, as you can see here, we have our linear equation, right? So it is commonly used to forecast the output of one variable based on the values of the other variable. The other variable will be considered as the input variable. Okay, so it can be helpful. Just suppose that here we have data regarding 2121, okay, year 2121. Suppose that here we have data, okay. Then, as we have this linear function, that is what we call a simple linear regression, we would be able, once we have here data, okay, whatever, we would be able to forecast, well, I will delete, okay, we would be able to forecast with this equation the number of companies I would have in Madrid in the year 2001, 21, okay? And apart from this, I will delete the example I have used. Apart of this, we have also another value, the R squared. It is called also the coefficient of determination. And the coefficient of determination is just the squared correlation between my two random variables. And it is very useful to assess how well our linear model will predict future values of our output variable. Okay, so here you can see how we have been working with two random variables, and we have started to analyze what relation we have between those two variables. As we said, we could also have an idea just by checking the numbers. If we check rapidly those numbers, okay, we can see that, well, in both cases, the number of companies are decreasing as we keep on advancing, okay? But this is just the first impression, okay? What we are obtaining here, thanks to the insert function option and thanks to this scatter plot and to the option of adding the trend line, what we have obtained here is deeper information that would also allow me to forecast or to make a prediction on the future values of my output variable. Okay, so that's quite interesting because Excel offers us a lot of possibilities. Okay, we have a lot of options to go deeper into our analysis. As I was previously mentioning, you will learn more as you keep on advancing on your statistics course. But at this moment, you just get an idea, or you are starting to be more familiar with all the functionalities that we have with our Excel file. Okay, just with two random variables or from INE here, you can see how in a few minutes we have developed a statistical study, and we can even tell a lot of information that we didn't have, because the first step was the covariance. Okay, I know I have a positive relation, but here, as you can see, we have gone deeper. We know that the relation is positive. The relation is very strong thanks to the correlation, but we even have a function, okay, that is telling me how this variable would evolve in the near future. Okay, so we measure the relation, how strong it is. We can even obtain a function that will explain us the relation between both variables, and we can even think about making a prediction. Okay, so try to work by yourself with these functions on Excel. Try to work with different examples, and just by using Excel, you will see how it is easier for you to use this program. Okay, thank you for your attention, and until the next video.